Good morning students, I hope you are following the physics video lectures. We are in the motion in the straight line unit. Today our goal is to learn about the acceleration. Let me begin our lecture. What does it mean by an acceleration? Acceleration is nothing but it is the rate of change of velocity of an object, and what it will tell, what the information will give by the observation of the body. So, the acceleration of the physical quantity which gives the information of the body how fast the velocity will changes. That means how the velocity is rapidly changing, it may be increases or it may be decreases, the acceleration will provide the information of the velocity changes. Then acceleration is called it as a rate of change of velocity of an object. Now let me go to the what is the mathematical expression for acceleration. Acceleration is mathematical expression, it is the ratio of change in velocity divided by time. So, it is the change in velocity to time interval. So, the change in velocity is represented with delta x divided by time interval is represented to the delta t. So, it may be represented with dx by dt also when if the time is equal to very small value. So, the change in velocity is nothing but final velocity of the object minus initial velocity of the body. Generally, the final velocity will denoted with v and initial velocity with the denoted u. The time interval is equal to initial time, final time interval t2 and initial time interval is equal to t1. This may be used, or initial time is equal to, let me take 0, then we can directly we can take it as a t. This is the mathematical expression. So, what is the units of acceleration means? The units we need to take the fundamental formula E is equal to, it is the rate of change in velocity. Directly I am taking velocity by time, velocity units is equal to meter per second, the time units is equal to second, then my acceleration units is equal to meter per second square or meter second power minus 2. What is the dimensional formula for the acceleration? So, velocity dimensional formula is equal to ml t power m0 l t power minus 1 is there, again the time is equal to t will come, that is equal to m0 l t power minus 2 will come. This is the dimensional formula for the acceleration. Now, let me go to the types of acceleration. There are mainly 4 types of accelerations are there. One is the uniform acceleration, another one is the variable acceleration, the third one is the average acceleration, fourth one is the instantaneous acceleration. Let me go to the for each one separately. The uniform acceleration, what does it mean by uniform acceleration? So, it is a velocity change if its velocity changes in equal interval of time in equal, so if its velocity changes equal amount in equal interval of time, however the small these time interval may be. So, what does that mean? So, if the body is changing its velocity, that velocity is must be equal for equal interval of changing time. So, then that acceleration is named as the uniform acceleration. Let me take like this, let me take this is the initial velocity of the body v1, final velocity of the body v2, the change in velocity is equal to v2 minus v1, here the time period is equal, let me take t1. So, again we are taking one more period that is equal to t2, if we are taking t1 is equal to t2, then here also again the velocity changes v3, then v3 minus v2 we are taking. So, these values must be equal as the time interval must be equal. What are they saying? If its velocity changes equal amount, so these value velocity changes must be equal. So, in equal interval of time. So, then the type of acceleration is called uniform acceleration. But one thing you need to point out here, even though the time interval is approaching to the small value, then this value must be equal, these two values must be equal. Now, here I am taking 10 seconds, even I am taking 1 second also, then these values must be equal. That is the definition of the uniform acceleration. Let me go to the another one. What is the variable acceleration? Variable acceleration means in the previous case, what is the change in velocity velocity amount must be equal for equal amount equal time intervals, that is called as a uniform acceleration. Here if the velocity changes unequal amounts, that means let me take in the previous case also, the body is starting from initial velocity of v1, the final velocity of the body v2 in the time interval of t1. So again the body changes to the time interval is equal to t2, again the body is reaches to the v3. Now what is the change in velocity? v2 minus v1 in this part. What is the change in velocity? v3 minus v1, v3 minus v2 in this part. Now what we will say, these values are not equal, even the time interval t2 is equal to t1. But here what is that one? They are not equal. That means v2 minus v1 is not equal to v3 minus v2. That is, this type of acceleration is called it as a variable acceleration or non-uniform acceleration. Now let me go to the another one. What is the average acceleration? It is the somewhat important. We will use this formula to solve the problems also. So this is defined for the variable acceleration only. That means the body is not a constant acceleration, it is changing its acceleration. What is the formula? Means the ratio of total change in velocity of the object to the total time taken. So how much velocity is changes to the ratio between the total change in velocity to total change total time taken, that is the average velocity. Let me go to the mathematical expression. For the mathematical expression for average acceleration is equal to, it will denoted with acceleration is equal to a, but I am iterating avg means average acceleration, total change in velocity divided by total time taken. The ratio between the total change in velocity to time taken is called it as the average acceleration. But change in velocity means a final velocity minus initial velocity divided by final time minus initial time. So that means this formula can be written as Vf minus Vi divided by Tf minus Ti. This is the formula we need to use. This formula is very important. We are going to use while solving the problem. Now let me come to this one, average acceleration. It may be having the positive values because of the acceleration may be increases. If the body is acceleration increase, the initial acceleration is equal to, let me take 10 meter per second square. It is the v1 initial velocity of the body. The final acceleration of the body, let me take 14 meter per second square. If we take the average acceleration means v2 minus v1 divided by time. It is the highest, it is the higher value compared to the 10. Then we will, if you subtract this one, means what you get, a positive value you get, that time we will get the acceleration is the positive value. That means if the velocity is increasing with respect to time, then the average acceleration must be provided the positive value. If the acceleration, if the velocity of the body decreasing, then what will happen? The average acceleration will provide a negative value. So because of, let me take in the reverse case, if the initial acceleration of the body 10 meter per second square, the final acceleration of the body, let me take 8 meter per second square is there. Now final minus initial is equal to what will get? You will get the negative value, then average acceleration is equal to negative term. So it may be 0 also. 0 also means if the acceleration does not changes, initial velocity and final velocity both are same, then it is called the uniform acceleration. Then that time average acceleration must be a 0 value will provide. So here I need to point out one more point here. Let me go to this one. Here let me go to here. What is here? So the acceleration is equal to velocity by time, as the velocity is the vector quantity. So acceleration is also vector quantity, which is, what is the direction of the acceleration? It will be direction towards to the resultant velocity direction, along the resultant velocity direction. Now let me go, what is the importance here? If you concentrate here, as the velocity may be, 1 minute please. Thank you. See, as a velocity, maybe it can have the positive velocity, it may be negative velocity, it may be 0 velocity, it became possible because of velocity can have the any, it may be positive, negative and 0 also will have. So then the acceleration will also be, we will get the positive and negative and 0 also we will get, because of it will depends upon the displacement. A positive displacement means a positive velocity will get, negative displacement means negative velocity will get, 0 displacement means we will get the 0 acceleration we will get, depending upon velocity is equal to displacement by time. So that is equal, it is the depending upon the displacement, it is the positive means positive velocity, positive acceleration. And this is the case we need to point out here. Let me go to the continuation of the fourth one. The fourth case is the mathematical, the fourth type of acceleration is nothing but instantaneous acceleration. So instantaneous means we are discussing the acceleration of the body at a point, at a given point or at a given instant. So it is the definition for this one: the acceleration of an object at a given instant or at a given time of the point of the motion, that is named as the instantaneous acceleration. The mathematical expression for the instantaneous acceleration is very important. So the limit value of the acceleration, average acceleration will provide the instantaneous acceleration. A instantaneous is equal to limit of delta t tends to 0, del v by del t we will get. So then we will get that dv by dt, where we are getting delta t value tends to be 0. What does it mean? The value, the time period value is going to be very smallest value. That means we are measuring the acceleration of the body at a short interval of time. That is the very important. Now will you please look on this one: dv by dt, instantaneous acceleration is nothing but it is a general definition of the acceleration only. Dv by dt, general in the subject we are discussing. Every time we will discuss only acceleration is the instantaneous acceleration only. At particular point we are discussing, that's why we are discussing dv by dt. Now let me go to the what is the acceleration. Is the value is equal to d square x by dt square. We should prove this one. A is equal to d square x by dt square. So how we can prove means acceleration is equal to rate of change in velocity, that is equal dv by dt, but velocity is equal to, we already having the velocity definition, that is equal to rate of change in displacement. Then with help of this one we will get the d square s by dt square. Here the displacement I am taking x, but in the problem we are taking displacement is equal to x, d square x by dt square, where we are taking s is equal to x, that is equal to displacement. This is the first equation proof. Now let me go to this one: acceleration is equal to v into dv by dx. Also we can use this one also. How we can use means, let me check here. I am using this space. So acceleration is equal to dv by dt we are having. Now I am multiplying with dx and dividing with dx. I am using this one. So this dv by dx is equal to dx by dt is equal to velocity. Then velocity is equal to dv by dx. This formula also we are going to use to solve the problems also. Then acceleration is equal to velocity of the body into dv by dx, the rate of change in velocity with respect to displacement. This is formula also we are going to use for the acceleration. Now this is the very important, the positive acceleration. What does it mean by a positive acceleration? Positive acceleration is nothing but if the velocity of an object increases with time. So that means the velocity at initial stage, the velocity is having 10 meter per second. Already we discussed this one. So our final state, the velocity is getting the 14 meter per second. That means the velocity is increasing gradually with respect to the time. So that type of acceleration we will get the positive acceleration. This definition is derived from the mathematical expression of acceleration is equal to final velocity minus initial velocity divided by time. So if the final velocity is larger compared to the initial velocity, then we will this value will be obtained with a positive value. That's why this type of acceleration is called as the positive acceleration. In the similar manner, you can tell that what is meant by negative acceleration also. Negative acceleration is nothing but it is the velocity of an object. If the velocity of an object decreases with respect to time, then that type of acceleration is called the negative acceleration. That means initial velocity is the larger. That means initial Vf is equal to larger. Let me take, this is the 14 meter per second square is there. Final velocity of the object is equal to smaller. Let me take, this is the 10 meter per second square is there. Then the change, the acceleration is equal to v final minus v initial divided by t final minus t initial. We will get this value, we will obtain a negative value. That acceleration is called as a negative acceleration. So the positive acceleration, well, we will get the positive acceleration. Generally we will observe if any vehicle is started from rest position, then the vehicle will approach a positive acceleration. Because of the rest position, acceleration is equal to 0. If the vehicle is moving, so its velocity will must be increases, then the acceleration will be a positive acceleration. When the vehicle is starting from rest position to it will come under to motion. Now the negative acceleration means when moving vehicle is applied a brakes, that will call it as a the velocity will definitely gradually decreases due to application of the brakes, then the acceleration we will obtain in this case is a negative acceleration. I hope you understand. Let me go to the one of the important derivation is there. If a particle is accelerated from a time t1 with acceleration of a1 and from t2 with acceleration of a2, then the average acceleration is equal to, this is the formula we need to use to solve the problem. What is that formula means? A1 t1 plus a2 t2 divided by t1 plus t2. So for the proof, let me take the object is moving in a straight line. So at initial state the body is having the initial value, initial velocity of the body is equal to u at a time t1 we are having. Now let me go to this one. If at a given instant of time, what is there saying at a time t1, what is at a time t is equal to 0, at a time t1 the acceleration of the body is having a1, let me take the velocity of the body is equal to v1. So at a time t2 what is the acceleration of the body is equal to a2, already they given, let me take this velocity is equal to v2. So what is the definition of the acceleration? Definition of the acceleration is nothing but the final velocity minus initial velocity divided by time taken, that is the formula we are having. So the total time taken is equal to t1 plus t2, this is the total time taken obtained to the objective. So see this, in this equation the acceleration A, average acceleration is equal to the final velocity of the objective v2 minus initial velocity of the objective v2 minus u divided by the total time taken is equal to, in this total process is equal to, what is the value? T1 plus T2. So this is the formula we need to use. How to use this one? Will you please look on this one? We need to get this v2 minus v1 value. How we can get means first apply the kinematic equation. So first v1 is equal to, what is the formula? V is equal to u plus at formula I am applying. V is equal to u plus at formula I am applying. So v1 is equal to initial velocity of u plus a1 into t1. So the velocity of the v1 is equal to this formula applied. Then v1 minus u is equal to a1 into t I am getting, a1 into t I am getting equation number 1. Now let me go to the, what is the second case I am taking, what is the velocity of the body at second case. So that is equal to v2 is equal to, just in this duration only I am applying, in this duration only. So in this short period the time is equal to t2, in this short period the time is equal to t1, don't confuse this one. So time t1 is, don't confuse, this is the time taken t1, somebody they may confuse here. See, t2 is equal to time taken to obtain the body from 0 to t, 0 to point B, don't confuse like this. This is the time taken to approach the body from a point of A to B only. This is the O, this is the O point. Now let me take what is the v2. V2 is equal to same formula I am applying, initial velocity plus initial velocity plus product of acceleration and time. Here is the initial velocity is equal to v1 is there, v1 plus product of acceleration is equal to a2 time, how much time is taken? T2. In the similar manner what we will get? v2 minus v1 is equal to, what we will get? a2 into t2 we are getting. So our goal is to get the in average acceleration, this formula we needed, v2 minus v1. To get this v2 minus v1, if you add this equation 1 and 2 you can get the value, just adding I am getting. So just add here itself. So v2 minus u plus v2 minus v1 we are getting. Here is the v1 is there, no, sorry, v1 left hand side I am adding, it is the LH side I am adding. Then what do we get? v1 and v plus v1 minus v1 cancel, that is equal to v2 minus u you will get. So the denominator, the numerator term we obtained, so the numerator term means just adding this right hand side two values, that is equal to a1 t1 plus a2 t2. So right hand side values also I am writing, that is equal to a1 t1 plus a2 t2, that is the values I am getting. So the total time taken in this duration is equal to V2. So T1 plus T2, then this formula is equal to A1 T1 plus A2 T2 divided by T1 plus T2. This is the very important formula we are going to use to solve the problems also. So I hope you understand this lecture. Thank you for listening. Thank you.